So Squirrel AI Learning is a AI-based adaptive learning platform. So we're currently only in China at the moment, but we have a number of collaborations throughout the world. So I'm actually part of an R&D team based in the US. So today, I'd like to talk a little bit about how AI can transform the education industry, specifically a little bit about what we're doing and what our vision is for the future in terms of how do we use AI for education purposes. So my role is I'm a senior learning and data scientist at Squirrel AI Learning. Basically what that means is I don't have an AI background. I have a cognitive psychology background. So my PhD was on how people learn, how they think, how we perceive, remember, and process information, right? And use that with data science, and more recently, AI. So really looking at the intersection of learning science, data science, and AI to try to find ways to enhance education using AI to specifically personalize education. So in the next 20 minutes, I'd like to cover these 4 topics, 4 points. Let's start out with, first, why AI for education? So let's talk a little bit about some of the ways in which we can think about how technology can impact education. So we find that this model to be really helpful. This is what's called the SAM-R model. We didn't build this, but we find it to be really helpful. So at the very bottom level, what you can see is technology can substitute, right? So technology can just substitute a teacher performing a common classroom activity and make it a little bit easier. So for example, Coursera, edX, those MOOCs, those massive open online courses, they're really good at providing essentially a replacement of what the teacher would do anyway, standing in front of the classroom, lecturing at you via a video-based platform. So you have, much greater accessibility to that kind of content. But it's exactly the same functionality. It's really just a teacher lecturing at you. The next level up, we can do augmentation, where the technology can actually augment by offering an efficient tool to perform common tasks. For example, a technology can provide automatic grading. So you can get feedback to students immediately so they know what they did wrong or right, and then, adjust, right? So that's augmentation. So at this point, substituting and augmentating are essentially enhancing education, not actually changing education, not transforming education just yet. At the next level up, you get a little closer. So what you're having here is that the technology can now modify the tasks that the teacher would normally do. For example, flipped classroom, right? Have you heard about flipped classroom before? A few of you? Awesome. So what happens is that as homework, the student could be watching a video or essentially, getting a lecture beforehand as homework, and then when they go into the classroom, they're doing practice-based group work that actually get at problem solving, hands-on activities with the teacher's guide. So at this point, you're beginning to get a little bit more effective. So you're moving beyond just the efficiency of augmentation, you're moving into the effectiveness, getting better, more effective at actually educating the students. Now, at the highest level, redefinition, this is where we think AI comes in. We can essentially redefine education. We don't just change the task, we change the paradigm. So we essentially flip education on its head. But we do that in 2 ways. The first one is essentially really pointing out what is the existing paradigm, which is passive learning, and what do we want to do is more active. So let me explain that a little bit. Passive learning is essentially, ironically, is what's happening right now. I'm a teacher standing in front of a classroom, essentially broadcasting the same information I'm expecting as students. You're processing the exact same information in the same way, at the same speed, and learn, and master the content by the time the bell rings. That's just not, it's just not natural. That's not how humans learn, right? So instead of just passively receiving the information, what we actually should be doing is by having students actively generating information. Instead of receiving the answers, students should actually be producing the answers, trying to find the answers for themselves. That's how we learn. And really, that's how we prepare for the 21st century. Another way in which we change the paradigm is we move away from this teacher or content-centric kind of view, where let's take the attention away from the teachers, okay? The sage on the stage kind of perspective, that just doesn't work in education anymore. Instead, what we should do is focus on the learner. So move the teacher from the sage on the stage and turn them into a guide on the side, right? So the focus is now on the students. What is it that the students need to learn? Everyone learns differently. Everyone learns at a different speed. Everyone has different interests, goals, prior knowledge, right? So how do we adapt and personalize to the students and moving away from just bombarding them with content and really have them interact with the content, okay? So we believe in this revolution of the education method. Essentially, we're saying every student is different. So frankly, group-based instruction is a waste of time. So instead, what we should be doing is use AI-based technologies to continuously adapt one-on-one, to give students a personalized tutor, giving them the content that they actually need at the right time in the right way, right? And we're not removing the teachers. This is something that whenever I go to conferences, I have to really, truly clarify. We're not saying that the teacher is out of the picture. We're simply changing their role. So now the teacher is no longer the one that's providing the primary source of information. Instead, they're now a coach. Think of it as like a sports team where you have a head coach that kind of, strategize what is it that students need to learn. And then the assistant coaches are really the ones that are providing the one-on-one attention. So essentially what we're saying is that the AI-based tutor are those assistant coaches, and the human coaches are the head coach. So the human coaches now are really the ones to provide targeted social, emotional support. And so they're the ones to engage students in the content, engage them in collaborative group work so that they can actually focus on challenges rather than just memorization. Okay, so our goal is in three ways. I realize the text is quite small for you all the way back there, but I hope you have a TV to see it. So we're moving from the traditional lecture center to the more personalized adaptive teaching. Okay, and at the bottom here, instead of just a human instructor, we're now combining the human head coach with the AI assistant teacher. And the one in the middle, I haven't mentioned yet, is that with AI-based technology, we can actually provide contextual and actionable analytics. We can continuously monitor what students know and don't know and change the paradigm, change the way they learn continuously. Rather than the traditional classroom where often when you want to collect data about students, you give them a test. And often it's at the end, like a final exam. That's often too late to actually make any changes to your instruction. Okay? So our goal then is to enhance the efficiency, to give the time back to students so that they can master what they need to do in order to solve problems, real-world problems. Okay? And then once we solve that, we're moving into how do we actually teach them to learn how to learn, to be more metacognitively sophisticated, to know how they think and monitor their own learning, right? So they can control their own learning. Those 21st century skills. Okay, so how do we do this? What is our approach? One way in which we have to kind of think about how do we implement AI? How do we make sure that the AI is actually producing value? The kind of educational equity is really what we're aiming for. And so the business model is truly important here, where the AI is truly the source of the disruption. We start with a problem, the educational problem, right? And it's really helpful, too, to support the business model if you have the social, economical, and political environment support. And in China, that's a little easier to come by. So we start there. Of course, we also need the AI expertise. So we need to know we need to have the elite researchers, those who can actually move the field forward. We need to have AI engineers and product teams who can actually turn those models, those vision into products. And we need those AI models and algorithms to actually be mature enough to solve real-world problems. Oftentimes, that's actually something that we struggle with. The third thing is data. This is kind of obvious, quantity and quality of the data, but also the ease of experimentation. And this is where a lot of our research partners are interested in us, in that they want to be able to use our data to actually inform the models, use the models to then collect more data, right? So continuous improvement, but also feed forward to standardization and kind of contributing back to the field to promote more research, more models. The last one is computing power. We have to have the technology to support what we do. So a lot of the problems that we're trying to solve, we have an inkling of how to do it, but sometimes the technology isn't there. The infrastructure may not be there. The scalability, the stack is not quite ready. So that's another area that we're working on. But in general, this is the 4 areas in which we absolutely need to implement our AI. Okay, so we're not alone, and we're surely not the first. I'm sure many of you have heard of at least one of these major players in the adaptive learning field. In fact, many of our employees and core leaders are actually, many of them came from these companies. So from them, we learned quite a lot, and we also had to adapt to the China system. So we learned that the B2B model, the business-to-business model, doesn't work in China. Frankly, I don't know if it works anywhere. If you've had experience in the US, you would know this is true. It's really difficult to sell directly to schools. So instead, what we do is B2C, sell directly to the consumers. We are an after-school learning market. And the fundamental models and algorithms still work really well, but specialization is not easy. By that, what I mean is that sometimes a single algorithm may work for math really, really well, but learning how to read is a completely different beast. Okay? You can't expect to just slap on the same AI and expect it to work. So instead, we actually have to build our implementation from scratch. At the core is actually the content. What is it that students need to learn? How they learn it comes after. Okay? And where AI comes in is entirely dependent on what is it that students need to learn. Okay? Often in other cases, we often find that data is one-dimensional. So what that means is that you often just get data from a single course, where students is taking a class, and you get data from how the students is doing in that class. Sometimes really, really great detailed data. But that's not enough, because now at this point, we actually want more comprehensive, more contextual, more historical data. You need to know, what did the students learn before, right? What did they do prior to this class? What are their goals? What is it that they actually want to get out of this class? What kinds of support do the teachers, the parents provide them? Really, the full picture. And sometimes we even get at the affective experience, the motivational engagement factors that students have as well. So really, in order to do this, you kind of have to go all in. You can't just have the AI. You can't just have the content. You can't just have, like the videos or kind of the setting. You actually have to provide all the things. And all the things means you have to have the AI, content, and service, and pedagogy. So the way that it works for us, is we have students come in an after-school setting where students are situated in a small group setting. Okay, so in front of them is a computer. And this computer is the one that's providing the adaptive one-on-one instruction. And the human coach is kind of always on standby. And the human coach also have their own supervising system, so that they can monitor what is it that students are doing. And sometimes, we're currently doing some experimentations where we're capturing students' faces to get a sense of their facial expressions. And we have a number of research partnerships where we could look at things like transdermal imaging, blood flow under the skin, to see how students might be stressed, what their heart rate might be. And sometimes the expressions can tell us if the students are frustrated, angry or sad or happy, right? Not saying that those are all meaningful, but that's an area of research where we're collecting data. We can see how informative is that data. It actually helping us to improve our learning experience. Sometimes we also have students wear a headset, an EEG headset, to measure their brainwave, to get at attention and focus. That's what the EEG is probably the most meaningful for at this point. Again, we don't know how useful it is yet, but we're trying things out. So let me give you another sense of how AI-based adaptivity could work and what does it require. So the first thing that it requires is very, very granular content. To identify exactly what students know and don't know, your content have to be granular enough, right? To be able to actually diagnostically measure what is it that they know and don't know. So this is just a small, very, very small subset of the knowledge components that students would need to know in middle school on rational numbers. Okay, so we're using a number of algorithms to determine where students is on this map. So I'm laying them out here as kind of boxes in a grid form, but it's actually a prerequisite network, a very complex network that we're talking about here. But the point that I'm trying to make is that, let's say these are the things that students need to learn. Some students already know a lot. So this particular student here only needs to know another 6%. Like this is the areas in which they're weak on. Another student could need a little bit more, and another student could need a lot more. So every student is different. So aside from diagnosing what students know and don't know, another thing that we really need to pay attention to is the individual differences in how they learn, right? And so I'm going to show you an example of, on this axis right here, it's just a random subset of students. These are a random subset of the knowledge components that they need to learn. And on the y-axis is the number of seconds that they need to master each one of these knowledge components. So take a single student, student number 7. The same student may require different amounts of time on different knowledge points. It's not like the student is a fast learner or a slow learner. It's entirely based on their prior knowledge, their interest, right? And their goals and any other relevant factors. On the other hand, for a single learning component, different students may require different amounts of time. So it's not that this particular, the cube root is easy or hard, but when and for whom, right? So those kinds of individual differences we are taking into account. Beautiful grid just to show you how varied the students are. But we need to be able to take these into account to provide personalized content recommendation. What content do we need to provide, and in what way, in what sequence do we provide them? That is where the power of AI comes in. This kind of thing could only be done with a one-on-one tutor in real life, right? But nobody could really afford that, or at least a very few of us in the world could actually afford one-on-one tutor with a very, very good instructor. So what we're saying is that AI could provide this solution in a much more scalable way and in a very effective way. Okay, I want to clarify one thing. Is that when I talk about the AI engine, I don't just mean the AI algorithm. In order to actually implement this solution, you need the AI algorithms, you need the content, the things that students need to learn, how are they going to learn it, the data, of course, we need to learn a lot from the data, and the pedagogy, right? So the instructional framework in which you're going to carry out the learning and the teaching. And some of the key success factors are just kind of laying out here. We want to be able to really just do 3 things with AI. Diagnose, to identify what students know and don't know, to provide recommendations of both content and sequence of content, to provide them with the kinds of interaction that truly engage them with the content, rather than just, giving it to them. They need to be able to think about it in a productive way and productively struggle sometimes. In order to learn something, you have to fail and struggle. And how do you do it in an engaging way so that students can kind of keep going, learn from their mistakes, right? And then another thing is optimal learning goals. We want to take into account students actually are pretty good at controlling their own learning if you give them a chance to do it, right? If you tell them, these are things you need to learn, usually they're a little resistant. But if you actually get them, right, to actually verbalize what is it that they want to learn, they become much more successful learners. And in China specifically, we have a lot of parental involvement, so we are capitalizing on that to provide students with adequate parental and environmental support. So as I said, AI could enable those 3 things, and these are the things that the teachers could get. Actionable insights in real time, optimize student engagement, because if they get exactly what they need, exactly when they need it, they often stay very well engaged. Continuous formative assessment, because we continuously collect data and inform student learning using that data. And we also empower teachers to focus on developing 21st century skills in a number of ways. And by 21st century skills, I mean those skills that get at how students learn, right? How do they learn how to learn, to control their own learning? And so I want to give you another more concrete sense of how AI can inform adaptivity. So there are actually 2 levels. The first one is something that I've already mentioned before, where the AI could actually inform what the task is. So what is it that students are doing now? What should they do next, and in what sequence? So it's a task-based kind of outer loop is what we call it, outer loop adaptivity. Now, within each task, let's say within a single question, you could actually use AI to figure out what is it that students actually need help with. One way in which we're doing that right now is using something called the virtual personal assistant. Really, what it does is it uses natural language processing, semantic analysis to engage students in a dialogue. So when students get something wrong, this is just a single example of physics. Students are dealing with a problem on reflective light. So they got an answer wrong. They picked a wrong answer. And so what happens is the VPA would now trigger a dialogue with the student, trying to engage them in a conversation where we would be asking the students to kind of like, can you verbalize your thought? What was your thought process going into it? And we can actually, what we get out of this is the reason underlying the mistake. Okay? Are there possible misconceptions that students may have that we otherwise just could not get at if we're simply giving them multiple choice questions? They could get something wrong. You can know that they didn't know it, but you have no idea why they didn't know it. Okay, so we're using this kind of technology to try to get at it. It still is a research area, but we're making some good headway. Okay, so these are some other research area that we're focusing on. We are primarily started out with knowledge graph-driven outer loop adaptivity. So the task-based outer loop adaptivity is what I talked about. Don't have time to go into all of these, but that's one area of research. Another one is something called contextual multimodal integrated behavior analysis. That's the video captures I was talking about, and bio-neural input analysis. That's the brainwave measures that I was talking about. So we're doing affective computing, we're doing different kinds of supervised and semi-supervised learning, a little bit of deep learning with those. We're also doing inner loop adaptivity. So I gave you a small snippet of an NLP kind of research domain, but we're also doing a number of other things where we have we're trying to cognitively simulate. So imagine if you can simulate a student, okay? That actually saves quite a lot of time at being able to just kind of predict how students would behave while at the same time really, inform your model of how students learn. Collaborative design, how do you group students? That seems to be a pretty simple question, but it's actually quite a complicated kind of thing to do. Should you group students based on common interest, based on common level of knowledge, or very different? So how well does it work? I know I'm out of time, but I can wrap this up really quickly. Yeah? Okay. So how well does it work? Well, the one way to figure that out is to do external testing. So these are just a sample of 4 different studies that we did using third-party research collaborations. So what that means is that someone's independent, a researcher comes in, do a randomized control trial, which is the gold standard of research, right? Treatment versus control, blind, like random assignment, and they use an external assessment. So pre and post test. So everyone takes a pre-test, split up the groups of students into 2 groups, treatment versus control. Treatment's the one that gets Squirrel AI Learning, and control is anything else. Usually in this case, it's regular traditional instruction or traditional tutoring. And everyone gets a post test. So all you have to do is compare pre to post and to evaluate the learning gains. So what we see here is really across the board. I'm giving a sample of 4 studies here, but we've done over 18. And the results are just very consistent across. So students who learn with Squirrel AI Learning outperform those who learned with traditional instruction. So they actually have better scores, and they learn the exact same content faster. So it's effectiveness and efficiency. And another thing is that a lot of the times they actually report better engagement, as you would expect, right? And I want to point out one more thing, is that some of these studies were done with a human teachers in a 1:15 ratio. 1 teacher, 15 students. In some of these cases, it's 1 teacher and 3 students, like what you would expect in a pretty decent, small size, classroom or small group tutoring environment. And yet we managed to outperform those situations as well. Okay, so this is our current distribution in China. We're actually only 4 years old. We were founded in 2014, late 2014, but we're currently in over 1,700 learning centers across 200 cities in China, and growing. We're looking to open 4,000 learning centers by the end of this year. And we're getting there. So how do we make this better? One way to do it is to establish collaborations with top international institutions. Many of them are actually in the US, but we're open to European partnerships. We are leveraging advances in learning science, data science, AI, and others. And others include, content development, user research, et cetera. Take advantage of standards, data sharing, open platform. We're very open about thinking about how do we later on open source our product. We're contributing very heavily towards standardization efforts. Of how to build an adaptive instructional system, how to use federated machine learning to share data privately, things like that. And of course, we are continuously improving on data. How do we get more data, higher quality data, more comprehensive contextual data, which is probably the most important thing. Continuous data-driven improvement. So this is where my research comes in, where how do we think about improvement using data? So it's not just about improving the AI, because I know it's an AI conference, we tend to think about using data to make the AI models better. But it's actually, that's only one area of it. Another part is how do we improve the content? How do we improve the pedagogy? We know a lot about how students learn, but in practice, it's not as easy to just implement what's often driven from research done in like an academic setting to actual real life. Okay, so these are just a subset of our research partners. We have research labs, joint labs set up at Carnegie Mellon University and SRI International at Stanford. And we actually have, so most of these, as I said, are in the US, except for, of course, Toronto, which is Canada, close enough, Sydney, Australia, China, of course, and we also are collaborating with an institute in Spain on AI. Okay. Just a quick thought on AI and ML in general. So kind of very much along with Pascal, what he was saying earlier, where small data is actually going to be the next big thing for us. We don't need big data. We don't actually want very big data. If we can get more contextual, well-labeled small data, we actually learn a lot more from that. Deep learning, we think, needs to go beyond perception, beyond pattern recognition, towards reasoning and understanding, because for us, causality is what matters the most. Actionable AI. So we often think about AI as being able to predict, right? Pattern recognize and predict. And that's the what kind of question. What is next, right? We're asking, so what? Like, what insight does that get? But even beyond so what, now what? What does that mean for us? How do we actually use that to act upon those kinds of insights to actually help our students learn? So thank you. We generally just look for partnerships in research, development, standardization, and philanthropy endeavors. And that's my email in case you want to reach out. Thank you.
Thank you so much. You're perfectly on time. You're perfectly on time, and I already see there are a lot of hands rising. So Teresa is coming to get you the microphone. We have questions over here. We have 2 questions, which are very important. Let's take both of them, huh?
Sure, yeah.
Thank you very much for this very inspiring talk.
Oh, thank you.
I have a question. How can AI be quick enough to do this job?
Be quick enough?
Yes.
What do you mean by that?
You have to train AI to recognize maybe some patterns. And you say your AI has to recognize the level of the student.
Yes.
Where to pick up the student, where he wants to go.
Right.
His goals. How can this be done in a quite reasonable amount of time?
It's actually being done right now in a quite reasonable amount of time because we're dealing with kind of a smaller subset of data, and we have enough students to just kind of rotate, right? So that we can actually apply existing models, do some quick modification, collect data, tell us what's going on, how well is it working, and then just go back and change the model and kind of reiterate. So that kind of iterative cycle is what we're good at. And that's where a lot of the research partnerships are interested in. So, yes?
Can you express it in microseconds?
Okay, not that fast. I'm talking about, well, let's say if you have a new model for adaptivity, like let's say for a small subset of mathematics, 7th grade algebra, I don't know, right? You could implement something, collect data over a period of days, and then look at the students' performance, because that's what we care about the most. Are students progressing? How are they interacting with the items? Are they interacting with items means questions in our case. How are they interacting with those questions? And are they doing so in a productive way? So we have metrics set aside to kind of evaluate those things. All we have to do is look at those metrics, those key performance metrics, right? And then so we're not doing like model, making changes to the model at a milliseconds kind of way that you're thinking about. But it's fast enough where, within a week, we can get some data back, with some performance data back that we can inform the next iteration.
Okay, we have 2 more questions, one over there, and then the one in the back, the young guy was a bit faster. But she's still there open for questions afterwards, I'm sure. Okay, your question, please.
Hi, I'm Martin Chupa. I'm presenting at the end of today's conference, and there's a lot of work that you've done, which is, how can I say, shadowed in some way, the work that we're doing. I work for MIBA, which is a neurotechnology company that's working in healthcare markets. And particularly with stroke, we're kind of re-educating, helping people to relearn through therapy kinematic actions that they've lost in the lesion. So it's a kind of education application in the therapy. And some of the things that you're doing in effective computing, we're working on the EEG side. So it's really interesting to see what you're doing. I can see a lot of parallels, which is the better word than shadowing, in what you're doing with what we're doing. So perhaps there's an opportunity for collaboration, and
Absolutely, let's chat.
I'll talk to you later.
Yes, thank you.
Okay, no question. So now there's the question in the back. The last one, unfortunately, but I'm sure you have time later. And please, when you raise your hand, ask a question.
How do you prevent students from having a one-sided experience? Because I think some learning tasks can't be put in some schematic.
Did you understand it? Can you say it again, because we didn't hear it perfectly here.
Sorry. I was wondering if how do you think to prevent students from having a one-sided experience? Because I think some tasks, some skills can't be put into a simple schematic. Because, for example, some anecdote can help you to improve your understanding of life.
You mean the personal experience by learning when you have a personal teacher. Did you understand the question? How do you give this personal kind of note to it? That they don't have only one-sided experience, right?
Right. So so we're tailoring the content. We identify what is it that you need to learn, right? And let's say you have the content. It's not all that straightforward either. We have a series of questions, kind of interactions that students could be working on to interact with the content. We have videos, right? And of course, we have that human teacher to engage them whenever needed. And that human teacher is actually really great, not just to supplement the AI, but a lot of the cases sometimes replace the AI or inform the AI. That's another area of research, is when we incorporate how do we use the teachers and their expertise to actually inform better teaching, AI's teaching.